Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 71 of physics, and we are dealing with the transfer of thermal energy. Radiation is the third process of heat transfer that we will discuss in this lecture. Unlike conduction and convection, radiation doesn't require a material medium for heat transfer. It can take place in a vacuum. For example, heat from the sun reaches the earth by the process of radiation, as you can see in this picture, ladies and gentlemen. That you can see that there is a sun and the earth is there. You must have to understand that sun releases the energy in the form of electromagnetic radiation, and that electromagnetic radiation can pass through the space as well. So it means that radiation doesn't require any material medium to transfer heat from one location to another location, as it can pass from the space as well. There is no medium in the space. Conduction or convection is not possible because of the vacuum between the sun and the earth. You can see that there is no direct contact with the sun and the earth. For convection and conduction, we need a material medium. So you can see that there is no material medium, so convection and conduction can never take place from sun to the earth. The sun emits electromagnetic waves of different frequencies and wavelengths, but with the same speed in vacuum. They are with the same speed. Remember, it is not that in the air the speed is one and the vacuum the speed is another. In the vacuum they are with the same speed. Ladies and gentlemen, in the picture below you can see, in this picture I means that there is electromagnetic spectrum is shown, and you will be astonished to see that there is a very small part of electromagnetic spectrum which human eye can detect. If I show you it particularly, then this area is called visible light. Human eye can detect only these lights, not more than that. From the left side, if you can see here, there is a radio wave. Then we are having the microwave, and then we are having the infrared radiation, and then visible light, and then ultraviolet radiation, which is coming from the sun. And then there are X-rays. X-rays are also electromagnetic radiation similar to the light, but of very short wavelength. So next is gamma rays. They are given in the order of longer wavelength, because radio wave is having very long wavelength and they are having very short frequency. So From longer they started and they are gradually going towards the right. Now, if I am talking about the visible light, then there are different color inside this which we are always denoting by Webgoer. This is violet, this is indigo, this is blue, this is green, this is orange, this is yellow, and this is red. On this side there is ultraviolet light which the human eyes cannot detect. Ladies and gentlemen, keep this in mind. And beyond the earth there is infrared radiation, and infrared radiation cannot be visible, is not visible to the human eyes as well. We cannot visualize these two color. Here it is also said that there is ultraviolet light and infrared. On the left side of this visible light you can see that there is infrared, and on the right side there is ultraviolet light. Ladies and gentlemen, infrared radiation is used for short communication, not for long distance communication, which is technically known as telecommunication. The remote control of your television is sending data from remote to the sensor of television, and they are sending data, but it is working in a specified area, not more than that. And we cannot see the infrared light as well. But I showed you all these things just because infrared radiation is making us warm. That is the radiation which is creating the heat, and we are feeling the heat. Ladies and gentlemen, one thing I want to say about the ultraviolet light, they are constantly coming from the sun, and our eyes cannot detect it. In fact, that is very harmful for the eyes of human beings. That is why we cannot see towards the sun, because ultraviolet rays are coming from the sun constantly, and if we are seeing it, then our eyes are feeling ache inside it. That was the thing I wanted to convey you. So let me tell you, light is only part of this spectrum of electromagnetic waves. The part of the spectrum that makes us feel warm is the infrared waves or infrared radiation. Remember, ladies and gentlemen, the heat which is produced due to infrared radiation is called radiant heat. I am writing it for you people here, that the heat due to the infrared wave is called the radiant heat. Beside the sun, hot objects like a hot iron also emit some radiant heat. The hotter the object, the greater the amount of radiant heat emitted. Keep these things in mind. If the iron is very hot, then it will do what? That will radiate greater amount of radiant heat, remember. Now, this is the definition of the radiation which I wrote in blue. Radiation is the continual emission of infrared waves from the surface of all the bodies transmitted through space without the aid of the material medium. So there is no need for the medium to take place in case of radiation. Ladies and gentlemen, in this picture I shown you all the three processes in one picture. There is fire here. On the left side of it, the phenomena of conduction is shown how there is a metal rod, which is this one, and one side of that rod is placed in the fire. So as a result, that rod is transferring the heat from the hot end to the cool end, and we discussed that in very greater detail. Then the second process is the convection. Ladies and gentlemen, do you think that there is a convection when we are letting the fire and we are warming our hands with it? Yes. Convection is taking place because above the fire in this region there is a high density of air molecules. They become hotter very soon. As a result, they are agitated by getting kinetic energy, and then they become highly when first they are highly dense, then the density is lower and it moves upward. So a convection current is taking place. Now above in this area, the air molecules, they are having low density. So when they are getting the low density, so it is coming down, and the high density molecules are moving up, and in this way the convection is taking place. Yes, because medium is required for convection, and that might be a liquid or the gases. In this case, gas is playing the role of a medium. Air is the combination of different gases. So we are here observing the convection. Now radiation is also, this object is feeling hotter when they are around the fire. This radiation emitted from the hot object in the form of electromagnetic waves is called thermal radiation. So on this side we are observing radiation, in the middle convection, and on the left side we are visualizing the concept of conduction. So all the three processes in one frame. Next topic is the absorption of infrared radiation. Ladies and gentlemen, very important topic. Infrared radiation is absorbed by all objects and surfaces. Yes, infrared radiation is absorbed by all these surfaces, and objects, the absorption causes a temperature rise. Uh, yes, when we are wearing dark colors clothes in the summer, for example black color, because black color is the good absorber as well as good emitter of heat. So the radiation coming from the sun, they are absorbing it, not reflecting it, because black color is a good absorber of radiation. That is why in the higher classes, in the A level, we will study black body radiation. There is a gray body radiation as well, but we will talk about the black body radiation and we will observe that through a graph. So ladies and gentlemen, on one side, if it is a good absorber, those black clothes, so when they are absorbing the radiation from the sun, so on the other hand, they are emitting as well very quickly towards the skin of our bodies. So we are feeling very hot inside dark color clothes. So that is why it is said that do not wear the dark color clothes in summer. Okay, I wrote all these things in the red. You can see infrared radiation is absorbed by all the objects and surfaces. And in the green, I wrote the absorption causes the temperature rise. Yes, when we are wearing black color clothes, they are absorbing the heat and they are increasing the temperature of our body. So remember that the topic name which is given at the top, absorption of infrared radiation. Every object and every surface can absorb infrared radiation, which is causing the increase in temperature. On the other hand, there is another topic, and that is emission of infrared radiation. As I told you that black body is a good absorber as well a good emitter of infrared radiation. So we are now talking about the emission of the infrared radiation. Infrared radiation is emitted by all objects and surfaces. This emission causes the temperature to fall. Yes, when you are emitting it, so the temperature is falling. Remember that from one side, if the radiation is absorbed by the dark color clothes, on the other hand, it can emit as well. So you have to think on the winter, not with the perspective of summer. We will think on the winter. So it is when you are coloring white your rooftop, it is reflecting the sunlight, not absorbing it, it is emitted. So as a result, we are observing 2 to 3 degrees centigrade decrease in the temperature. So in general, you have to remember a good emitter of radiant heat is also a good absorber of radiant heat. In other words, conversely, you can say a poor emitter of radiant heat is also a poor absorber. So that is why we are wearing not that dark color clothes, and we are wearing the non-dark color, which are very poor emitter as well as a very poor absorber. Okay, one thing I must say, and that is the nutshell, and this sort of questions might come in your paper, and I wrote this here. Dull black surfaces are better emitters of infraradiation than shiny white surfaces. Dull black surfaces are better emitter. That is what I told you, that if a surface is a good absorber, they will also be a good emitter as well of infrared radiation than shiny white surfaces. Shiny surfaces are always emitting the heat, reflecting the heat. They are not emitting, they are reflecting it. They are not allowing it to be entered in the surface. That is why we are wearing those clothes of a very mild color. Okay, next topic is factors affecting the rate of transfer of radiation. There are many factors which can increase or decrease the rate at which energy is transferred, and that is totally depending on the three factors. The first factor is color and texture of the surface. As I told you, dull black surfaces are better emitter of infrared radiation than shiny white surfaces. And also, I told you that the rate at which infrared radiation is emitted is higher if the surface is dull and black. So on the color and the texture of the surface is also increasing or decreasing the rate at which energy is transferred. Now the second factor that is used is surface temperature. The rate of transfer of energy by radiation also depends on the surface temperature. The higher the temperature of the surface of the object relative to the room temperature, we are comparing that with the room temperature, the higher the rate of energy transfer. And let us observe this in a graph. Ladies and gentlemen, this is the area which is showing the room temperature, and the vertical axis is showing the temperature, and the Horizontal axis is showing time per minute. You can see in this area from the gradient of this line, and you can see that the triangle is a longer one. So it means at the beginning in less time, if I am considering this time, this is a little time. So rate of temperature of decrease is high. If a body is very hot at the beginning, it will emit the radiation from the surface very quickly at first. And then you can see that this triangle is of middle size. So it means gradually with the passage of time, the temperature decrease is slow. And at the end, just above the room temperature here, the rate of temperature decrease is low. So the surface temperature is also affecting the rate at which energy is transferred by radiation. From the graph you can see at the early stages the temperature is decreasing with a very high rate, in the middle with the middle rate, and at the bottom in this area the rate of temperature decrease is slow. Now the third factor which is affecting the rate of transfer of energy by radiation is the surface area. The third factor which affects the rate of transfer of energy by radiation is the surface area of the object. If we compare two objects of the same mass and made of same material but having different surface areas, the object with the larger surface area will emit infraradiation at higher rate, and the object having a small surface area will emit the radiation with lower rate. So radiation emission is affected by three factors. One is the color and texture of the surface. The second is the surface temperature. And the last one, the third, is surface area. So you have to keep in mind these things. Ladies and gentlemen, I have to stop here because the next topic is very longer, and we will see the consequences and everyday application of energy. We will see the good sides as well as the bad sides of these conduction, convection and radiation. That's a big topic, so I have to stop it here. Wait for that topic in the next lecture. Tomorrow we will take that. Thank you for your stay with us. Allah Hafiz.